So we're going to practice our equation word problems today. So the big thing about word problems, the hard part about them at the beginning is defining our variable. So what defining a variable means is determining what the unknown of the story is and giving it context, unknown of the story. So we look at this first one. I have a number. If I double the number, then subtract 6 from the result, then divide the answer by 2, the quotient is 20. The best part about defining the variable, it's always going to be related to this very last sentence. So whatever this last sentence is it's basically going to tell us what our variable needs to be when we define it. So what are we trying to define? X is going to be my number. Feels strange to kind of define this one because x is a variable and basically just represents a number. But in the context of the story, it's this number here. So if we set up this problem, I have x. I'm going to double it. Means I'm going to multiply it. I'm going to subtract 6 from it. And then I'm going to divide the result by 2. So this whole thing is going to get divided by 2. Which then gives us the answer of 20. To get rid of this 2, or to solve this, we have to multiply by 2 on both sides. The 2's cancel, gives us 2x minus 6 equals 40. Add 6 to both sides, gives us 2x equals 46. Divide by 2. So the number I was thinking of was 23. All right. Next one, Jill sold half of her comic books, then bought 16 more. She now has 36. So let's define our variable. With how many did she begin? So it's a weird way to say it, but basically it's saying is how many comic books did she start with? So X is going to represent the number of comic books to start. The more detailed we can be with our defining of the variable, the better off our problem is going to be. If we just said X was comic books, is that comic books at the end? Because it's just 36. Is it comic books before she bought the 16? Before she sold half? Like, what are we talking about? So number of comic books she started with. So here's the number of comic books she started with. First thing she did was sell half of them. Then she added 16. That leaves us with a total of 36 right now. We can subtract 16. We get x over 2 equals 20. Multiply by 2. And x represents 40. 40 what? Comics. Chris and Scott work as electricians at $14 and $12 per hour. If Chris worked 10 hours more than Scott and their income was $3,520, how many hours did, this should say they, each work? Ooh, yikes. So this one's a little bit tougher because if we wanted they, we could go something like this. X is a number of hours Chris works, while another letter, Y, is a number of hours Scott worked. But now we have to deal with 2 letters, and I don't want to do that. So they gave us a little bit of extra information. Chris worked 10 hours more than Scott. So what that is telling us, that the number of hours Chris worked is the same as Scott's plus 10. So all we have to do is figure out how many hours Scott worked, and we've got it. So we're going to set it up. $3,520 were earned. We're going to take the number of hours Chris worked, and we're going to replace it with this number of hours Scott worked plus 10. with the hours that Scott worked. Chris makes $14 an hour. Scott makes $12 an hour. So that was a lot of information that just happened, so I want to make sure I pause here to make sure I didn't lose any of you guys. So this 14, let me say it this way. This statement right here is all about Chris. Chris makes $14 an hour, and the number of hours he works was 10 more than Scott. So if Scott worked, let's say, 10 hours, Chris worked 20. So 10 plus 10 gives me 20. This statement right here is all about Scott. He makes $12 for the number of hours he works. This one is the money. So that's how I built this statement. That way I only had one letter in the entire thing. One other way you could have set up this problem, and you get the same answer in the end, is we could have 14x plus 12x minus 10. This is saying basically the same thing. Instead, we're using Chris's number of hours to relate it to Scott's. So we're saying Scott's hours are Chris's minus 10. So either way, we could solve it and get the same answer. I'm going to stick with the green one, though, because I wrote it first, so I'm just going to stick with it. I distribute, I get 14y plus 140 plus 12y equals 3,520. Combine my like terms, I get 26y plus 140 equals 3,520. Subtract the 140. I get 26y is equal to whatever the heck 3,520 minus 140 is. I believe it's 3,300 something. I want to just know exactly 3520 minus 140. Yep. 3,380. Divide that by 260. So y is 13. So let's go back to the beginning. Y is the number of hours Scott worked. So this is Scott's hours. Chris worked 10 more. So x in this case is 26. Not 26, that's not double. Come on, Carl, I'll get it together. 23. Sorry, I looked at 10, 20, it's like, that's double. Idiot. It's 23 hours. Container A has 200 liters of water and is being filled at 6 liters per minute. B has 500 liters of water and is being drained at 6 liters per minute. How many minutes will it take for the two containers to have the same amount of water? So it even told us right here what we're going to define our variable as. We're going to use m for minutes. Alright, so when I look at this is what information is most closely related to our variable, the minutes. Well, the first thing that's most closely related is this 6 liters per minute. When we see the word per, much of the time we see 6m like this. So the other one's being drained at 6 liters per minute. So in this kind of problem we have two sides. This is container A, this side's container B, and we know we're going to set up an equal sign like this because we want to know when they're going to have the same amount. So if it's being filled at 6 liters per minute, to the 200 start value, while the other one had 500 and is losing 6 liters per minute. So we have container A, all the information about container A, 200 and positive 6. Container B, 500 and negative 6 for the minus. Get rid of this so I can solve it. Can't have m on both sides, so I'm going to add 6m. Add 6m. I now have 200 plus 12m equals 500. Subtract 200 from both sides. 12m equals 300. Divide by 12. And m equals, so I have my calculator here. Let's see what we got. 300 means divided by 6, so that's 50. So it's going to be 25, I think. Yep. So it's going to take 25 minutes for these containers to have the exact same amount of water. So Bob has a coin collection. Let's skip this one. Move on to this one. So I want to set up this problem. I took this right from the CMAS practice test. So you can see one that is like one's on our CMAS test. So high school is having a talent contest, and we'll be giving out different prizes for the best 5 acts in the show. First place wins the most money, and each place after wins 50 less than the previous place. They want us to create a model to determine the total amount of prize money based on the value of the first place prize. So what they're telling us right here, based on the value of the first place prize right here, they're defining our variable for us. So x is going to be first place prize. Again, we want to be a specific prize. Let's say money, prize money. Okay? So first place, we don't know how much they win. They just win some amount of money. X. Second place, third place, fourth place, fifth place. So this is first, second, third, fourth, fifth. Second place is whatever is 50 less than what first place got, which means this one is 100 less than what first place got. This one is 150 less, all the way down to $200 less than what first place got. So this is what the model basically looks like. Now in part B, they're going to offer $1,000 total dollars in prize money. So that tells us we're going to have to add all of this together, and it has to be $1,000. So I don't need the plus sign at the end. I didn't mean to put that one. I was just kind of in plus sign mode. So I'm going to erase this part. Try to clean it up a little bit. Don't need all these lines. Get rid of that plus sign. Like that. All right. Got to add this plus sign back in. Now to solve it, we're going to combine all of our like terms. So we have 5x, and then negative 50, negative 100. So I'm going to kind of put these together in a special way. I'm going to put the negative 50 with this one. That's negative 300. This is all just scratch work here. And then negative 100, negative 200 is another negative 300. So we get negative 600 when we combine all of our like terms. Equals 1,000. We add the 600 to both sides. We get 5x equals 16. Oops. That's 16,000, 1,600. We divide 1,600 by 5. And x is $320. So first place gets $320, but we haven't actually answered part B. I need to know how much is each prize. So down below I'm going to create some space. First, second, third, fourth, fifth. We can use our model to help us. We could also know we're just going to subtract 50 continually. So we get 320, which then gives us 270, which is 220, 170, down to, 120 as the final prize. To ensure I set this up and solved it correctly, These all should add to 1,000. I just want to make sure I did it right. 320 plus 270 plus 220 plus 170 plus 120 is 1,100. Uh-oh, I made a mistake somewhere. What did I do wrong? Total amount of prize money, so it's each place after that is 50 less than the previous place. Okay, we set that up fine. Oh, oh, geez. I'm sorry. Negative 150. This is supposed to be 200, which means this right here is 500, which means this is 1,500. 1,500 divided by 5 gives us 300 for our place. I knew that didn't sound right as I was going. Like, I don't remember getting 320 the first time I did this. So really, first place wins 300, then 250, then 200, then 150, and then last place gets 100. Again, I want to make sure I didn't make any mistakes because, you know, I'm an idiot here. 300 plus 250 plus 200 plus 150 plus 100 is 1,000. Okay, feel kind of dumb. 150 plus 50 and 150 is 200, not 300. Man, can't believe they made me be a math teacher, right? All right, so that is our word problem review.